Hello everyone, I welcome you all in the session of vibration, and I am going to make this lecture especially for GATE and ESE examination point of view. So today's our objective is what is vibration. Second objective is where it occurs, and the next objective is why. Why we have to study vibration. The answer of the first question is what is vibration? It is a term that is recognized when someone hear it, and it has plenty of advantages and a lot of disadvantages. Means I mean to say it has both positive and negative aspects. So here the question is, what are the positive aspects of vibration? We know when we play guitar, it produces a very soothing music and we enjoy it. Another, I can give an example, that is vibrating mode of our mobile. It alert us without disturbing anyone. So there are many advantages of vibration, as well as there are two negative aspects. As a mechanical engineer, the first negative aspect is the old running engine produces noise. Okay, why it produces noise? The answer of this question is because of in running engine there are reciprocating and rotating parts. That's why it produces noise. Okay, so our main objective to study vibration is this one. Is there any way to eliminate? We cannot totally eliminate the noise, but we can minimize it, no doubt, by some means, by some balancing and another approach. Another negative aspect is you know it very well, earthquake. It is very dangerous, and it may lead to, or I can say it can be lethal. Okay, so this is the introductory part, that is what is a vibration and where it occurs and why it is to study, because it leads to noise. Okay, so I come to the main point. What is the definition? What is the definition of vibration? So I am defining it as to and fro motion of a system about its mean position. What do you mean by mean position? Particularly, more precisely, we say it, this mean position is nothing but equilibrium position. Okay. So, in any system, how it occurs to and fro motion of a system? At the school level, we have already studied the motion of a pendulum. Okay, there is another term, that is oscillation. Invariably, we used this word oscillation, pendulum oscillate, not pendulum vibrate. Obviously, pendulum oscillate about its mean position. We have already read it. Means it repeats its motion after a definite time interval, and the motion is continued after motion is continued in the absence of external friction or external dissipative environment, and it continues for infinite time if there is no any dissipative environment. So we say it as oscillation. So here is generally both the term vibration and oscillation is used synonymously, but we can differentiate it a little bit, but both the terms are almost synonymous. We say that anything in the world which contains mass and elasticity are capable of vibration. Any system which has these two properties, no doubt mass and elasticity is inherently present in any system. So generally we say invariably everything in the world vibrates. Why vibrates? Because it contains a mass and elasticity. Okay, so the main objective to study vibration in mechanical engineering is no doubt for a mechanical system, and mechanical system consists of some reciprocating and rotating parts. So in order to eliminate the noise, we have to study it. How can I minimize the noise if there is a vibration due to some operating mechanism in the machine? Okay, so to study the vibration, I am taking a simplest model, and this simplest model is the spring mass system. This is the simplest model. Okay, before starting this particular model, we have to know a certain terminology, and the basic terminology. The first one is where we are going to what are the topics which we are going to study, and the topic which I am going to discuss first is degree of freedom. Okay, we know degree of freedom is defined as minimum number of independent variables required to define the dynamic system completely. Okay, so in GATE and ESE engineering services examination, the syllabus is only limited to single degree of freedom. 1 degree of freedom means 99% of the time the question asked in GATE and ESE is from single degree of freedom. Okay, so no doubt the obvious answer is any system which has degree of freedom is unity. Okay, but we have to know the idea about degree of freedom. If we say कि a particle, what will be the degree of freedom for particle in 3-dimensional space? A particle has only 3 degree of freedom. Why? Because it can only translate. It has no dimension, so it cannot rotate. So it has only 3 freedom, that it can translate in x direction, in y direction and in z direction. It cannot rotate about x direction because it has no dimension. It is a point, it is a dimensionless. Okay, so rotational freedom is not there. But if we asked for a rigid body, means a body having a finite size, so it has 3 translational plus 3 rotational component, so its degree of freedom will be 6 in 3-dimensional space. Okay, and if we talk about a deformable body, let's understand with an example. Suppose this is a cantilever beam and the load is acting, so it will be a deformed like this one. So if I am asking what will be the number of independent variables to define the system completely, come here, to define the system completely. So here, in order to define system completely in this particular system, so the response, very important is response. So a response in this particular system is nothing but deflection in the beam. Okay, so here we observe that the deflection at each point is different. In fact, at this location deflection is 0. At this location deflection is 0. At this location at free end the deflection is maximum. And the number of points are infinite. So degree of freedom will be infinite. There will be infinite degree of freedom in this particular case. Means if there is a deformable body, so degree of freedom in the case of deformable body will be infinite, because we required infinite number of independent variable to define the system completely. Okay, so we are only limited to single degree of freedom system, means only one independent variables required to define the system completely, only one, in case of GATE and ESE point of view. Okay, now I am coming to this position, why it is a single degree of freedom system. Because only one variable is required to define the position of this particular mass during motion. How the motion will occurs? When we displace downward and leave it, then what happen? Actually the spring will be stressed and there will be spring force which acts upward, and the mass will go up. Again the next is the spring is compressed and apply force in downward direction, then then mass goes in downward direction and the motion is continuous because there is no any dissipative environment. Okay, I have already considered no dissipative environment here. Okay, so actually vibration motion, in order to study there are three aspects. Mean motion is classified as something like this. If the motion is classified as, this is the here response of the system is this displacement. Why displacement? If we say the displacement of this particular mass is this much, then we can identify the position of this particular mass. Okay, so I am plotting the response is here displacement. Okay, see in our study basically response is measured in terms of displacement. This is displacement, and the derivative of displacement will be velocity dx by dt. I am writing it as x dot. X dot is dx by dt, means this will be velocity, and next is the derivative of velocity, that is x double dot, nothing but d2x upon dt square, that is acceleration. So we will learn the response of the system in terms of displacement, velocity and acceleration. Okay, so generally in the world, in real life situation, the oscillation which we are study or it happens, it follows a certain we can say it follows a certain shape, you can say certain shape. The shapes are the different shapes we study are, first one is, suppose the response I am plotting here is a displacement in at ordinate, and this is a time. So first response can be like this one, suppose. Second response, second representation is, this is displacement and this time, and let it looks like this one, and I am drawing third response is like this. Let it look like this, then become 0, then again it comes to like this at some position, then become 0. Okay, this response is termed as harmonic. Means the response of the system means displacement, basically we can say displacement from the, this is the mean position, displacement from the mean position is varying harmonically, means it is a combination of or linear combination of sine and cosine series, sine and cosine series, means displacement can be written as the linear combination of sine and cosine series. Okay, here the term is, here the response is something different. Okay, how it difference? Because it does not varying sinusoidally, means it is non-harmonic, and in the third case the distribution is like this. So what is the conclusion here? Here the mean position is this one. Again, the mean position is this one. But in this case, mean position is shifted. It is not this one. Mean position is shifted to at this location. It is shifted upwards. Okay. The next observation is this is harmonic, but this is non-harmonic. It is also non-harmonic. Okay. So if we want to convert these non-harmonic function into harmonic function, we have a tool, that is Fourier tool. Using Fourier tool we can convert it into a harmonic one. Okay. Similarity is all three motion are periodic, but first one is harmonic and these two are non-harmonic. So here we can conclude that all harmonic function are periodic, but all periodic function are non-harmonic. Okay. So in today's lecture we have just studied about the response of the system, that is a displacement, velocity and acceleration, that is the response, and the three parameter we have to study, that is the harmonic and non-harmonic function. And in the next lecture we will study about the mean position and the motion analysis. The motion analysis I mean to say that is the equation of motion. How to write the equation of a motion for a given system. Okay, thank you very much.